lesson on inverse functions. But let's begin with a joke. How does a backwards poet write? In verse. Pretty funny. If you know what an inverse function is, you know that's funny, because that inverse function is kind of like a backwards version of a function. Let's check. So to begin our conversation about inverse functions or relations in functions, let's begin here. Let's say we have an original function, f of x. Here are our inputs, here are our outputs. An inverse of the function is written like this. We have this little -1, looks like an exponent. That means an inverse of this function. Watch what happens. It's very simple. Let's not overcomplicate this. Basically, to find an inverse of a function, you reverse the x and y values. You swap them. So that y value of 0 became the x value, and that -5 of x value became that. So the next point is going to be 1, -3, and the next one, 2, -1, and the next one, 2.50, and the last one, 3.50. We've just swapped the x and y values, or you can think of it as swapping all the domain values with all the range values. That's what an inverse is. But an inverse does something interesting graphically. Let's take a look. Well, first of all, let's recap the domain here. So domain is from -5 to 2. And of course, I'm showing this -5, and I'm using the inequalities here, -5 to 2. So I'm implying it can be any point between those values as well. It's not just these discrete values, which is important. So let's assume that this is a continuous graph and we're just showing some points on it. Okay, -5 to 2. All right, the range is y values from 0 to 3.5. Oh, this should say y here. I should make that change. 1 second. Okay, so I couldn't make that change. But anyway, this should say y because it's the range, so 0 to 3.5. So what's the domain and range here? Well, let's see. Oh, I guess I'm going to plot the points first and come back to those in a minute. So these points I'm going to plot in blue. Okay, so -5, 0 is here. -3 and 1 is here. And then -1, 2. And there's our 5 points that we're given. Connect them, because I said we're going to assume this is a continuous graph or function. Okay, now let's plot these points. I'm going to do these in green. 0, -5. 1, -3. 2, -1, and the last two. Looks like that. Connect those. There's an interesting relationship between those. Can you spot it, or do you remember it maybe if you've learned it last year? Well, the relationship is this, that these two functions, when two functions are inverses of one another, they are reflections of one another over the line y equals x. You can see these are perfect reflections over this diagonal line here. So now, let's jump back to the inverse and talk about domain and range. What's the domain? Well, the domain is x values from 0 to 3.5, and the range is y values from -5 to 2. Now, like I said in the beginning, when we find the inverse of a function, we just swap the x and y values. So now look at what we've done with the domain and the range. The domain of the original, right here, became the range of the inverse, and the range of the original became the domain of the inverse. So we're just swapping all the x and y values. Okay, so with that in mind, I want you to go back to, in your mind, let's go back to mapping diagrams and remember what the definition of a function is. Remember, a function is a relation in which each input produces only one output. So with all 6 of these here, the question I want to ask you is the original a function, and would the inverse also be a function? And, well, first of all, okay, let's see if you remember. Is this a function? In that first case, yes, it is. Every input leads to only one output. Even though the two inputs, 3 and 6, both lead to the same output, each of them individually only leads to one output. So it is a function. Would the inverse be a function? And now think about what we talked about inverses. Inverses, you're just swapping the x and y values. So in terms of the mapping diagram, look at the mapping diagram backwards. Think of these now as the inputs and these as the outputs. So looking at it right to left now, is it a function? In that case, the answer is no, because this time the input of 9 produces 2 different outputs. So looking left to right, inputs to outputs for the original function, and then backwards to check if the inverse is a function, because the inverse is just the x and y values swapped, right? So try that for this next one here. Is the original function, is the inverse a function? Original, yes. Inverse, no. And for the same reasons as the first one. You can see when you look at it the inverse way, the backwards way, the 3, if that's your input now, produces 3 different outputs. Okay, great. Next one. Is the original function, is the inverse a function? Yes and yes. Both ways when you look at it, you have a relationship with one input leading to one output and backwards as well. How about the next one? No and no. Okay, looking at it this way, these are the inputs. This input of 2 produces 2 different outputs. Looking at it backwards now, if these are the inputs for the inverse, the input of 40 produces 2 different outputs. How about this one here? Yes and, ooh, I'm out of order here. Okay, so we have yes and no here. No, because looking at it backwards, input of 0 produces 2 different outputs. And then here, no and no, going the normal way, the input of 9 produces 2 outputs. Going backwards in the inverse way, the input of 1 produces 2 outputs, and so does 2. Okay, I hope that gets you thinking about functions and their inverses. Again, just one way and then the reverse way for the inverse. Okay. Now let's focus on this one a little bit more. The only one of these that had yes and yes, where the original function is the original is a function and the inverse is also a function. And notice that one is 1 to 1. 1 leads to 1. 1 leads to 1, okay? That is the only time where a function and its inverse will both be functions. The original relation and the inverse will both be functions when it's 1 to 1. If it's anything but 1 to 1, then you cannot have a function both ways. Okay, so a 1 to 1 function of f that maps a onto b will have an inverse function, there's that notation, that maps b onto a. Okay, so a 1 to 1, basically what that's saying is a 1 to 1 relation is the only one where the original and its inverse will both be functions. Okay, we just saw that. If f of x equals y, then f of -1, or the inverse of y, equals x. Okay, that's showing that swapping of x and y values. So now, with all that in mind, we have an example of 1 to 1 here. All right, because we see this way, these inputs produce 1 output each, but looking at it backwards also, these outputs produce only 1 input, right? So both ways it works as a function, therefore the original and its inverse are both functions, and therefore it's 1 to 1. So what is f of 2? Oh, by the way, here's f, and here's the inverse going backwards, right? What's f of 2? F of 2 is 12. We can see input of 2 produces output of 12. Great. What's the inverse of 18? That means now you're looking at it backwards, right? So this is not your x value, it's like your output, and you're saying what output produces what input. So f of the inverse of 18 is 3, because you can see it here. That 18, when you go backwards running the inverse function, you get back to an input of 3. Okay, f of 6. F of 6, well, it's not on here, but we can see a pattern here. 1 leads to 6, 2 to 12, 3 to 16. We're just multiplying by 6 every time. So that means f of 6 would be 36. And now f inverse of 66. So if you went backwards, imagine you have the outputs. The 66 one will produce some input. What will it be? Well, if you try to follow this all the way to 66, and you remember the relationship is times 6, then this is divided by 6 going backwards, so it must be 11. 66 divided by 6 will be 11. Okay, so f of 2, you're looking for an input of 2. Go from here on the x-axis, go up, the output is 5, like that. Okay, how about the inverse? Now when you're looking at the inverse, it says 9. That's no longer the input. You're saying if the output is 9, what's the input? Okay, so you start at 9 this time. And this is one way to think about it, right? You're saying if I had the original function, the output would be 9. That's what this means here when you have the inverse. So what x value leads to y value of 9? So you have a y value of 9 here. I go across, I go down, and that input must be 4 to produce that. Okay, now solve this equation. So again, notice in this equation, you're given the inverse. So you're saying In the inverse relationship, let's turn this around to the f of x relationship. Let's try that. So you're saying if the input was 1, the output would be a, right? I wrote it back as a regular function. You can always swap, remember, you can swap these two when you change from a function back to its original or inverse. So inverse back to original, I swap those. F of 1 equals a. So your input is 1. When your input is 1, what is the y value? It is 3. So your answer there is 3. Okay, great job. We'll see you soon.